This is MBF3C, Foundations of College Mathematics, Grade 11, and my name is Marvin. Welcome to the second week of classes, and this would be class number 4, as you can see on the screen. This is where we finished off last week, and we'll pick up from here today and move on. But before we do, I want to just backtrack a little bit and go back to something we did earlier last week when we were talking about the vertex form of the equation. Because I realized after our last class that we only did one example where we did the table of values and we used the table of values to draw the graph. And from that point forward, we use Desmos to do all the graphing for us, which is great, and we're still going to use Desmos, but I want to show you a couple of things about graphing that we didn't talk about last week. So I'm going to scroll back up here, and this is all material that we covered. So we're going to go back to lesson 1 just briefly. So if you remember, I'll go back up to the one that we did. If you remember, we plotted and graphed the most basic or equation, which is y equals x squared, and then everything that we do moving forward, we're going to compare to that one. So transformations means how do we get from y equals x squared to the new graph. So we plotted, sample problem number 1.1, we calculated the values for y and created a table of values, as you can see there on the screen. So what I want to point out is that the one that's highlighted in yellow, right in the middle of the table of values is 0, 0, which is the vertex. We talked about this before. So that's the vertex. And if you notice that the numbers above and below are mirrored. So right above 0 is 1. Right below 0 is 1. Right above 1 is 4. And at the bottom, right below 1 is 4. Right above the 4 at the top is 9. Right below the 4 at the bottom is 9, and so on. So going upward, we go 1, 4, 9, 16, 25. Going downward, we go 1, 4, 9, 16, 25. So this is a mirror image. So from -1 to -5, and from 1 to 5, we're going to get a mirror image. So when we graph that, and I'll just come over here and do that for you now. So y equals, just in case you have forgotten what it actually looks like, y equals x squared. So what I mean by a mirror is the right side of this parabola, that's what the graph is called, it's called a parabola, is identical to this side. So another way of looking at it, if I take this paper, if this were on a sheet of paper, and I were to take the paper and I would fold it along the y-axis, that vertical line, if I were to fold it, these two parts of the graph would match. They'd be in the exact same spot. So that's what I mean by a mirror image. So, and again, so you can see the mirror image on the graph, and you can see the mirror image by looking at the numbers. So when we plot graphs, what we want to do to make sure we capture the left side and the right side off the graph is we want to put in this highlighted spot right here, we want to start with the vertex. Put the vertex there, and then we can go down by 1 and up by 1 on the x values, and then calculate the y values. So let's come back over here. Let's scroll down. And again, we only did one of these. So we're going to do another one now. I'm going to scroll down until I get to it. Apologize for all of the scrolling, but this is all material we've covered before. And again, all of the blue stuff is new material that I've added, and anything that's in red is the solution. Now, sample problem 1.8 create a table of values to graph y equals 2 times x minus 3 squared plus 5. Okay, so you got to be able to draw the graph without using decimals and then use decimals to check your work. So this is the vertex form of the equation. So 3 comma 5, 3, 5 is a vertex, but at the same time, so if we do the calculation, just to show that this is indeed the vertex, if x is 3, if I substitute x is 3 into this equation right here, y equals 2 times 3 minus 3 squared plus 5. 3 minus 3 is 0. So get 2 times 0 squared plus 5. 0 squared is 0, and 0 times anything is 0. And then 0 plus 5 is 5. So if x is 3, y is 5. X is 3, y is 5. So we don't need to do this calculation. I'm just doing the calculation for you just to show you that it is indeed correct. 3, 5 is indeed the vertex. So what we're going to do now is we're going to go from 3, we're going to count down. So I'll count down from 3, I'll get 2, 1, 0, negative 1, and negative 2. Now, the x values won't mirror each other. 3, going to go up now, so 4, 5, 6, 7, 8. So the x values don't mirror one another, but the y values will. So now what I'm going to do is I'm just going to copy this to make it easier, and I'm going to paste it up here. Oops, cancel that, and I'm going to paste. So now I'm going to change my x value to 2. So the x value is right here. So that becomes a 2. 2 minus 3 is negative 1. So it's pretty easy to do. We're just going to change one number basically and then do all the calculations. So a negative 1 squared, that means a negative 1 times a negative 1, which is a positive 1. Positive 1 times 2 is 2, and 2 plus 5 is 7. So when x is 2, y will be 7. Now let's come back up here and let's do the same thing again. The only thing is this time the x value is 1. 1 minus 3 is negative 2. Negative 2 squared is 4. 4 times 2 is 8. And 8 plus 5 is 13. Let's do the next one. And this time the x value is 0. So 2 times 0 minus 3 is going to be negative 3. And a negative 3 squared means a negative 3 times a negative 3, which is 9. 9 times 2 is 18. And 18 plus 5 is 23. Let's keep going. So if x is negative 1, in this case, so negative 1 minus 3 is negative 4. And a negative 4 squared is 16. And 16 times 2 is 32. Sorry, 32. And 32 plus 5 is 37. And let's do the last one at the top. So now we have x is negative 2. So we're going to put 2 times the negative 2 minus 3. So minus 2 minus 3 is negative 5. And negative 5 squared is 25, and 25 times 2 is 50, and 50 plus 5 is 55. So those are all the values. So let's put those numbers in the y column over here. So that is going to be 55, 37, 23, 13, 7, 5. So now let's get down in here. Now we're going to go to the other side of the vertex now and work our way up. So now we have 4 minus 3, and 4 minus 3 is 1. 1 squared is 1, times 2 is 2, and 2 plus 5 is 7. Notice that. So here, so 3 comma 5. So right above we had 2, 7, 4, 7. So you probably guess what the value of y will be here when x is 5 by just looking at the y column above. Let's do the calculations just to verify. So let's paste that. So now we have 5, x is 5, minus 3. 5 minus 3 is 2. 2 squared is 4. 4 times 2 is 8. And 8 plus 5 is 13. So when x is 5, y is 13. Here comes the mirror. So we have 7, 7, 13, 13. So you could probably guess the next one's going to be 23. But let's do it just to verify. So if x is 6, 6 minus 3 is 3. 3 squared is 9. 9 times 2 is 18. And 18 plus 5 is indeed 23. So there we have 23. And we'll keep going. So just so that you have an example to follow if you are working through some of the key questions. So here we have x is 7. 7 minus 3 is 4. So now 4 squared is 16. 16 times 2 is 32. So 32. And 32 plus 5 is indeed 37. 37. And I'm going to run out of room at the bottom of this page. So 7, 13, 23, 37, 55. 17, 13, 23, 37. So we know this one's going to be, we don't need to do the calculation for the last one. We know it's going to be 55 because this is a mirror image. So what you could do now is if you come over to here, and so 3 comma 5, so 1, 2, 3, 5, that's the point 3 comma 5 right there. So that's where the vertex is going to be, right there. And then we're going to have 4, 7, and 2, 7. So it's going to come down like so, and then go back up here. So now let's graph that one as well. I'm just going to make this a little bit smaller. Okay, so we have y equals, so now we're going to type in, just to make it quicker, the equation. Y equals 2 times x minus, what did we say it was? 2 minus x minus 3 squared plus 5. X minus 3 and are going to square that. Square, and then plus 5. Like I said, there is the point 3 comma 5. There's 4 comma 7. Oops. can't get to 2 comma 7, but that goes through 2 comma 7, and then 5, 13. There's the point 513, and there's the point 113, it should be. Okay, so this is how you would do the calculations right here. And then you plot those points on a sheet of graph paper, and then you could draw freehand, and then you can use Desmos to check your work. So that's the one example that I want to go back to just to make sure you understand how to do the graphing from the vertex form of the equation by doing the table of values. And the more points you have on a graph, the easier it is to graph. So if you only did 1, 2, let's say 3 or 4 or 5 points, you would have a lot of points to draw a curve. Whereas if you're doing a straight line, all you need is 2. You got 2 lines, 2 points, sorry. Grab a ruler, draw a line. Covers the entire graph. Graphing parabolas and curves are not quite that easy. So you need a few more points than 2. Okay, so we've checked that. So now let's move down. So that is the vertex form of the equation. Lesson 2, we're talking about polynomials and factoring. You'll see my email address on the screen, marvin.osmond@nnecschools.org, and my number is 807-738-2031. Those are 2 ways you can communicate with me. The phone number is a cell number. It's my personal cell phone number. You can text, call. It's probably best if you text first just to make sure that I'm available. And then I can give you as much assistance as you need. I can help you with the with the support questions, but not the key questions. The key questions you're on your own. So these are polynomials, and again, we looked at, come back up here again. So polynomials made up of 2 or more terms. So poly means many, nomial means terms. So all of these right here have 1 term. So those would be, well, these right here, negative exponents, or with the variable in the denominator of a fraction, those are not considered polynomials. You can have a variable in a fraction if the variable is on the top, but not when it's on the bottom. And these types, if you were to graph these, you get I wouldn't say weird looking graphs, but different graphs. But anyway, just keep that in mind. So we have here, this one here has 1, 2, 3, and terms are separated by addition and subtraction. So 7x squared means 7 times a number squared. All of that is 1 term. The minus 4x is a second term, and the plus 2 is another term. It's called a constant term. Constant means it doesn't change, and it's simply a number or a value. Whereas the 7x squared and the 4x, they can change depending on what we choose for x. So remember, the x are values that we choose, and it can be any value from negative infinity to positive infinity. Now, depending on the type of problem we're working on, that will help us determine what values we're going to choose for x. Okay, sometimes we don't need to use a negative number, sometimes we do. Okay, so we have that, say, trinomial. Here, you'll notice inside of the bracket, we have x minus 4. So x minus 4 has 2 terms, and that is called a binomial. And the value in front, the 3, by itself, that's a monomial. Mono in mathematics means 1. Bi means 2. Tri means 3. So we have monomial first, 1 term. Binomial, 2 terms. Trinomial, 3 terms. Once they go beyond 3 terms, they don't have any special names. So it will be a 4-term polynomial, 5-term polynomial, 6-term polynomial, and so on. Okay, so when we have a number, so a constant term like this, a monomial times a binomial, what we need to do is we need to multiply the 3 multiply everything that's inside of their bracket. So I got to go 3 times x, 3 times a negative 4, and 3 times x is 3x, and a negative 3 times 4 is minus 12. Okay. In here, we use the word parentheses, and that simply, in layman's terms, it's brackets. Okay. So you'll probably hear me refer to them as brackets instead of parentheses. This one we have a monomial which is 2y. So it's not just a constant term, it's got a variable, it's a variable term. And then we have a binomial inside the bracket, 3y plus 2. So again, we have to multiply 2y times 3y, and then 2y times 2, 2 times 3. The numbers in front of the variables are called coefficients. 2 times 3, so multiply the numbers, you get 6. Y times y is y squared, plus 2y times 2 is 4y. We don't say y4, okay? It's not wrong, but in mathematics, we always write the constant term or the number first before the variable. So number before the letter, okay? So that's how we multiply monomials times a binomial. So we did a couple Thursday last week. So let's work through some more. So we'll go through a fairly simple one here. And we are going to, okay, let's come back over here. Just gotta come and left. Okay. So again, we're going to change the text color to red because we're working on a solution. So now we have to multiply the negative 3 times t, negative 3 bracket. The bracket in mathematics means we are multiplying, and then subtract 3 again times positive 4. And close bracket. So this means a negative 3 times t, then negative 3 times a positive 4. So let's make that red. And I'm just going to copy that. And so a negative 3 times t is a negative 3t. And a negative 3 times, negative 3 times 4 is minus 12. So a negative 3 times t plus 4 is a negative 3t minus 12. Okay, so these are ones where we had a variable or a constant multiplied by a binomial. So now let's do a couple where we have like this one right here. Oops, undo that. So let's do, and change the text color to red. Okay, so now, and when you notice too, when we're working with equations, we always put an equal sign at the beginning of each line, okay, because we are simplifying. So 7 times x plus 1 is equal to 7x plus 7, okay? So we have to remember to use the brackets, or sorry, the equal sign. So now we have 8k times 4k plus 8k times a negative 10. Oops. So now, let's simplify that. So let's go to insert equation, and again, it's going to be in red. So that's going to equal, move that over a little bit, So try to keep the equal signs underneath one another as well. So 8 times 4 is 32. K times K is K squared. So I need to get that. Where is my equation? Okay, let's get to there now. Okay, so I need to, I've lost my equation tool, so I need to make that a K squared. So 832K. So where is my equation editor gone? Not there. I'm looking for, let's try from the beginning again. So delete that, insert equation. Here we go, now equals 32K. And then the K needs to be squared, 32K squared plus 8K times a negative 10. So a positive and a negative in mathematics when we're multiplying means negative. And 8K times 10, 8 times 10 is 80. And then don't forget the K. So 8K times 4K minus 10 is 32K squared minus 80K. Let's try the next one. And again, let's insert. Okay, so now, so that's going to equal, again, always use the equal sign, equals negative 5n times a negative n. So a lot of negative signs floating around here. Then minus 5n bracket minus 1. Okay. So now, I'm going to try to just, let's come down here and simplify that. So that will be equal to, so a negative 5n times a negative n. So let's look at the signs first. A negative and a negative in mathematics is positive. The number in front of the n is a 1, like I said last week. It's not written, but so 5 times 1 is 5, and then n times n is n squared. So let's square that. Positive 5n squared. And then a negative 5n times a negative 1, so negative and a negative is plus, and 5n times 1 is 5n. A negative outside of a bracket means a negative 1. So if we work through that one, this one's a little, I wouldn't say tricky, but it's one to pay attention to. So again, because there's no number there, it means negative 1. So that means it's going to be negative 1 times, now we got 3 numbers inside of the bracket this time, or 3 terms, so we've got to multiply negative 1 times everything inside the bracket, so negative 1 times x minus 1 times minus y, and then minus 1 times minus 1. So now we have to simplify that. So when we simplify that, it is, we have to be careful and watch the signs. Okay, so again, I'm going to make sure my equal signs line up underneath one another. A minus 1 times x, again, we don't need the minus 1, we can just write minus x. Minus 1 times minus y, minus and a minus is plus. 1 times y is just y, we don't need to write the 1. And then a negative 1 times a negative 1 is positive 1. So if you look from here, a negative outside of our bracket just by itself simply means toss away the brackets and the negative sign and flip all the signs inside. So the positive x becomes negative x, negative y becomes positive y, negative 1 becomes positive 1. That's a shortcut. So let's try another one. This is a monomial times another trinomial, but in this case, let's get into here again. Equals 2 times the 3x plus 2 times a negative 4y plus 2 times z. So let's simplify that. So we'll just do one more example after this one, and that should give you enough examples that you should be have enough to work through all of the key questions. So 2 times 3x, 2 times 3 is 6x. Positive 2 times a negative 4, a positive and a negative is a negative. 2 times 4 is 8y. And then plus 2 times z is 2z. And the last one we'll take a look at for today. This one is now so we're working at monomials, binomials, and trinomials. Now we have a bracket where there's 1, 2, 3, there are 4 terms. And like I said, this one has no special name. It's just a 4-term trinomial. But the same rules apply that we've been using all along. The value or the term that's outside of the bracket has to be multiplied by everything inside of the bracket. Okay, so that means that we have to multiply negative 6 times a negative 2a, close the bracket, minus 6 times plus 3b. Again, we don't need to write plus sign though. Minus 6 times a minus 4c, and then minus 6 times a positive 5. Now it's simply a matter of simplifying. So once you get used to doing this, you can go from the first step, you can go right from here to the final step, and you can omit this middle step. Okay, so once you've had enough practice, you can do that. But for now, let's just do that middle step until you become comfortable, and then at that point, you're free to stop using that middle step. So negative 6 times a negative 2 is a positive 12a. Minus 6 times a positive 3 is minus 18b. And then minus 6 times a minus 4c. Minus 6 times a minus 4 is plus 24c. And then minus 6 times a positive 5 is minus 30. So a negative 6 times negative 2a plus 3b minus 4c plus 5 is 12a minus 18b plus 24c minus 30. Okay, So that is called the distributive law or distributive property. I typically call it the distributive property, but this particular uh, the way they wrote this one, they use law, but it's the same thing. So now you have enough that you should be able to finish that support question. So we're going to move on to multiplying two binomials. So binomials would be like this: 2x plus 4 times x minus 3. So the two polynomials inside of the brackets are called binomials. So what you have to do, you have to multiply the first term in the first binomial by both terms in the second binomial. Then you have to multiply the second term in the first binomial by both terms in the second binomial. Now, there's a acronym we use. It's called the FOIL method. Okay, is used when we multiply two binomials. And in short, it means first, outside, inside, last. So we're going to multiply the first term in each binomial. So 2x, in this case, 2x times x. The two outside terms, so if you think about the brackets, the 2x and the minus 3 on the outside. We're going to multiply 2x times the negative 3. We're going to multiply the two inside terms, which is the 4 and the x, and then the two last terms in each binomial, which will be 4 times negative 3. Okay, so when we multiply two binomials, most of the time you're going to end up with a trinomial. Okay, not always, there are a few exceptions, but for the most part, that's where you will end up. Okay, so again, there's an example here. When we multiply two binomials, most likely the two middle terms can be combined because they are like terms. Now in mathematics, we can add and subtract like terms. So 2x plus 5x is 7x. Okay, 3y minus 2y is 1y. So we can add and subtract like terms. Like terms means that the variable term, the variable part, the letter, has to be the same. So in this particular case here, we had 2x squared minus 6x plus 4x minus 12. The 6x and the 4x are like terms, so they can be combined. So minus 6x plus 4x is minus 2x. So we end up with 2x squared minus 2x minus 12. So this is called the FOIL method. So there's another example, and the solution is there for you, work through for you. I'm not going to go through that one because I want to do a couple of sample problems for you. So these are, again, they are in blue. So this is new material that has been added since the material was sent to you. So this is extra practice for you. So we have to multiply x times x. So again, equal sign, and we're going to go x times x. So that's the first term. Then we've got to go the outside terms. So plus, now I'm going to go x, oops, because it's just the way we are going to, oops. Okay. X times 5. Is that the way they did it up here? I just want to check to make sure that I'm following the same. So 7x plus 7x times 5 and minus 3 times x minus 3 times 5. x times x, x times 5, let's go back up here, 2x minus, okay, so x times x times 5, then we got to go the two inside terms, which would be plus, 3 times x, and then plus 15. Now I'm just going to come back and fix this one. I'm not really fix it, but when we multiply and we have a constant term and a variable, we put the constant term first. So let's switch these around. Let's make this 5, 5, and then make this x. Okay. Now, when we multiply, I'm going to show you just, I'll come down here. When multiplying even 2 or more integers, the order doesn't matter. So here's an example. 2 times 3 times 4, 2 times 3 is 6 times 4 is 24. 2 times 4 times 3, same three numbers we're multiplying. 2 times 4 is 8, 8 times 3 is 24. We can go 4 times 3 times 2. 4 times 3 is 12, times 2 is 24, or we can go 4 times 2 times 3, 8 times 3, 24. So the order in which we multiply doesn't matter. So when I go x times 5 or 5 times x, it means the same thing. Okay? So now let's do the simplification. And I want to do insert, what do I, insert equation equals x times x is x squared. So we need to square that. So I did that by using this. So x squared plus 5x plus 3x is plus 15x, and then plus 15. Okay, so I'm kind of leaving out the one step here. Actually, I probably shouldn't, because we're going to get some more complicated ones. So let's just do, let's just try and do a copy and do a paste. So that's x squared times, this would be plus 5 okay, so I'm just going to fix this because for some reason I'm outside of the equation here. Okay, I'm going to move this to the left again and stay inside here. So it's going to be x squared plus 5x plus 3x plus 15, and that simplifies to plus 8x. I made a mistake earlier, so it's a good thing I went back and did this. 5x plus 3x, not 15x. It's 8x plus 15. So it's easy to make a mistake if we start skipping steps. So we'll keep it like this for now. Okay? So let's try another one. So we're going to try some, you notice that these are very similar. We get x plus 5, x plus 5, x plus 3, x minus 5, x minus 3, x plus 5, x minus 3, x minus 5. So what we're doing is we're just changing the signs inside, and we're going to see what it does to each of the trinomials. So like I said earlier, when we do this, uh, when we multiply two binomials, we are going to end up with a trinomial. So 1, 2, 3 terms, trinomial, and this is a binomial, x plus 3, and x plus 5 is also a binomial. So let's work, this one out. So x plus 5, so I'm just going to copy, actually I'm going to copy all of this, and we'll just do the editing to it. I'm going to get rid of that. Okay, and why I didn't want it to do that. Okay. So we're just going to mess around with it a little bit just to get it all lined up here. So x times x is x squared. So this is going to be now a minus 5 because it's a negative inside in front of that x, in front of the 5, times x plus 3 times x. And then we have, and again, I should up here, I should have put, this would be 3 times 5. And this would be here, it's going to be plus 3 times a negative 5. Close the bracket. So again, brackets means we're multiplying. X times x is x squared. Minus 5 times x is minus 5x. Plus 3 times x is plus 3x. Plus 3 times negative 5 is negative or minus 15. The two terms, so if I just highlight this for now, so I'm going to highlight because those terms are the same. So the x, right here, so plus 5, plus 3, I'm going to highlight that again. So those terms are alike. Minus 5x plus 3x are alike. So they can be combined or added and subtracted. And so now a negative 5x plus 3x, so negative 5 minus plus 3 is negative, minus 2x, and then minus 2x minus 15. So you notice that they're very similar. This was x plus 3 times x plus 5. We ended up with a trinomial x squared plus 8x plus 15. Two binomials again, x plus 3 times x minus 5. Gain the middle of terms. Most often when we're dealing with binomials like this, we're going to end up with like terms in the middle. Not always. We'll see some where they're not, but in most cases they are. So negative 5x plus 3, think of a number line if you need to. So negative 5 plus 3 is negative 2. So this gives you enough now that you should be able to work through key questions. Oh, let's get down here. And key questions 1 and key question 2. Okay, so that's all the time we have for today. Thank you for participating. Again, my contact information is there, marvin.osmond@nnacschools.org, 807-738-2031. And you should try to submit your lessons as soon as possible. Tomorrow we'll pick up here and finish off this particular lesson. Thank you and bye for now.